Hello everyone. Here, here we are talking about air passenger traffic for San Francisco Airport, along with Arun and Amrinder. I'm going to quickly take you to our Shiny app that we have created for everyone to use, since everybody doesn't have our studio, which we have coded into. So they can go to this link and click. They can use our Shiny app to forecast any kind of data that they have. So our app will take only text files, which has only one column. So you just have to have one column with the values that you want to forecast. And if you have a header, you can skip the first line. Then you're gonna have to enter your starting year, month, and the data frequency. It could be in months, it could be in weeks, it could be in years. I'll show you quickly our sample file. So basically, this is a passenger count for San Francisco Airport, as you saw the data set. I have a header line, so I'm just gonna skip one line, and then it's gonna give me the results. I think my data starts at 2005, and it starts at July month. So as you can see here, we have Arima forecast model. It also tells us if your data is stationary or not. It also tells us ACF, which is a correlation of your data, if your data is correlated or not. uh, and pretty much anybody can come here and upload their file and get the same result that we got. I'll pass on to Arun now to talk more about our project.
All right, thank you, Shaishev. As you can see here, we are doing the air passenger traffic for the San Francisco airport. So as you know, it's one of the most busiest airports on the West Coast. Maybe not as busy as LAX, but quite busy as well. So what's the main purpose that we're trying to do here? We're trying to see is the consistency, is the numbers from on a monthly basis, the air traffic patterns on a monthly basis from January to December, and if they are consistent from year to year. So is there a consistency in the peak seasons and the down seasons? Are they consistent and from year in and year out? And obviously with COVID-19, it has affected the 2020 numbers. So as of March of 2020, the numbers were significantly went downwards, or in some cases were almost near zero due to safety and health protocols. So obviously a lot of airport revenue, a lot of air passenger traffic was gone. Most places were empty, and the revenue was completely affected. So do other major airports in the United States or West Coast have the same effect as San Francisco? Of course. I mean, this pandemic has affected all of us, and it's affected all airports. Next slide. So why do we want to use this data? As you can see by our Shiny app and the data, we want to forecast the future. We want to see what these airports, and especially these major airports, what they're going to do, not just currently, but in the future as well. Like especially now with post-COVID soon to be coming up, I think with the vaccines are coming, and how will some of these airports recover some of the revenue that they lost in 2020? And this is some of the key facts that we want to look into. Can we use our app and the data we collected to help airports handle the influx of passengers that may want to travel in 2022? Because with most of their plans and most of our plans that were canceled in 2020, most people have the urge to travel. So how can these airports handle the high influx of air passenger travel? Because it's going to even spike up even more. And what kind of strategies are airports going to use to recover some of the revenue in terms of duty-free, concessions, retails? With so many people traveling, how are they going to target all these customers? And these are some of the things that we want to look into as well. And now I'm going to give it over to Amrinder. He's going to look at the evaluation portion of our presentation.
Thank you very much, guys. So the main thing that we are focusing on right now is the forecasting thing. And to start with that, we need to actually plot the time series data. And the first thing which we had to do was to create a new table for the date, because the date that we had, it wasn't in the format available. It was in the year and month format. So we converted into YYYY MMDD format, which is the common accepted format for time series. And when we plot the data, we can clearly see that there is a constant spike in the number of passengers over the period of time. If you see from 2006 to 16, yep, the spike has been increasing over the period of time, even surpassing 4.5 million. And to get a clear picture, we can also see the graph based upon the activity type. If we see, we can now clearly distinguish between the number of deplaned uh, passengers, the passengers who actually took the flight, and the passengers who were just through transit. But the main thing, the forecasting, that was achieved using the Arima model. Arima model, when it comes to forecasting, a key assumption for time series data is that of stationarity. This is like where the main variance and autocorrelation of series are constant. The reason for this assumption is that if, for say, mean variance and autocorrelations of series, they're not constant over the period of time, then it makes it a lot harder to make predictions. Because if you have a constant pattern, it's very easy for the model to understand as to what's going to happen in the near future. But if you see varying spikes, then it's really difficult. Through visualization, we can see the zigzag pattern, which basically does not change over the time much. But when we tried conducting the Dickey-Fuller test, we saw a p-value of 0.01, which basically which provides the null hypothesis is rejected, and the hypothesis that the data is stationary comes into play. So for that, we use the Arima model. We use the function auto.arima. This is the function which basically gives us the various possible coordinate values that can play around. The coordinate values basically have PDQ, which has been mentioned in the report. The best model configuration is basically the one which has the lowest BIC, that is the Bayesian information criterion. We used that configuration model, and based upon that, we found out the RMSE and MFE values. These are basically the errors that we get for while finding the accuracy and while forecasting the data. So the values were 641.12 for RMSE and a negative 9139 for MFE. Since the MFE is negative, the data set is kind of overcasting. And this is quite obvious because we already saw that there is some over forecasting because of the number of passengers which actually didn't catch the flight. So it is supposed to happen, and some situations like seasonality and correlation, autocorrelation is present there. We already saw in one of the graphs which Shasha showed us in the Shiny app. So if there is correlation, autocorrelation present, seasonality present, so there is supposed to be some over forecasting. So Arima over here does not account for change points or specific shifts in the trends in time series, although it is technically possible in Arima while we work in R, but we need a package like AED forecasting for that. So while Arima has accounted for such patterns such as seasonality and autocorrelation in time series, it appears to lack the utmost accuracy for the model. That is quite evident for sure. But it may be possible for Arima that it would excel when forecasting data with a more clear defined trend or one that does not particularly exhibit seasonality. So we saw clear signs of this in the data set that we have in question. So yes, it can be improved if the data was less stationary. Yeah, thank you.